Alright guys, today I'm going to be going over the ERC-20 Smart Contract Standard. So for those who don't know, the ERC standards are just basic templates for making smart contracts that do a particular thing. So ERC-20 is for fungible tokens, ERC-721 is for NFTs, may be replaced soon by ERC-1155, which supports both non-fungible and fungible tokens. And so there's all sorts of different standards that do different things. Today I'm going over the simple fungible token standard, and so yeah, this is going to be great for people who are trying to get into DApp development, and for people who are trying to make NFTs. I think this is a very valuable video where you can understand what's going on. I'm going to be going over the main overall contract, concepts, major things that make ERC-20 tokens fungible. And so yeah, let's just jump right into it. So I already have an ERC-20 thing set up here. I'm going to remove it all so you can see how I do it from the very beginning. And so I'm even going to just make a whole new file entirely. So as you can see in my directory, let me refresh. So I just have a blank directory here, almost blank. There's something else in there, don't worry about it. I'm just going to touch fungi token.sol, stands for Solidity, and when I refresh you should see it pop up, and I can type ERC-20 and VS Code automatically gives me the full implementation as a snippet, all fully loaded up. That just automatically loads, which is perfect. So here you can see, I like to change this to just 8.0 and above, just like that. That's just the Solidity version. Different Solidity versions compile the contract differently. Small things like when you exceed the maximum value of an integer, does it reset? Does it, things like that. They may be different depending on the Solidity version. And so yeah, so this contract has the interface and it has the actual contract. So the interface, for those who are familiar with Java, are more familiar with it, and other programming languages do something similar. But the interface outlines the functions that somebody wants to implement. So somebody might go to a programmer and say, hey, I want these functions, for example, balance of, and when you run the function, you give it a parameter called owner, and I want it to return a balance integer. So there are functions like these inside the interface, and then you have the actual contract that the programmer makes that implements all of the main functions. So that's what we're going to be going over today, is these functions. So as you can see, nothing is implemented in the interface. It just defines the function and gives a little bit of details of what you want the function to actually do. And so as you can see in balance of, like I said before, we're taking in an address type called owner, and we're returning an integer called balance. So smart contracts on Ethereum, Polygon, Binance, these are going to be using Solidity files. But on other blockchains like Solana, you'll be using different environments. You might be using Rust for Solana, and there may be a couple others. But here in Solidity, we have the way it works is that when you run a function, you're actually doing a transaction. So you are the message sender. When you send a message to a smart contract, you simply send crypto to a smart contract, and your address is recorded as the message sender. And as you can see right here, message sender, this is just the person sending the money to the smart contract. And depending on different checks, verifications, validations that you do, you can perform different things. And a function may change state. So if there's a variable in the function, for example, an integer that represents somebody's balance of the token, if you change that, that's going to cause a state change for the smart contract. And that is what is important for determining how much things cost. For Polygon, things are pretty cheap, so you don't have to worry about it so much. But for other blockchains like Ethereum, it may be a lot more expensive. So here, as you see, balance of, down here you can see the implementation, balance of, it just simply returns balances owner. What is balances owner? Well, the owner is the parameter that we pass in, that's the wallet address of the owner, but balances is actually a mapping that's defined inside of the contract right here. So mapping balances, this is just given a key address, it'll give you the integer that represents the balance. And so this is the mapping, so there's going to be a long array basically of addresses. Each one represents a key that associates with a value. So a bunch of key value pairs. You can see there's other mappings. This one is a mapping of address to another mapping of addresses to uints. So this is just the allowance. The allowed user is able to do different things. This is extra functionality that's not commonly used, but I will still go over it, maybe briefly. So that's the balance of function. Now we're going to get into the transfer function. So as you see, this one takes in two parameters, the to and the value, and it returns a simple boolean. A boolean is just a true or false, and it's going to return that. So let's go see the implementation. So transfer, here we go. So the first thing is going to require that the balance of the sender, the address of the person contacting the smart contract, the balance is going to be retrieved, and it's going to do a check if it's greater than the value that the owner, the message sender is trying to send. Because obviously if someone is giving the smart contract 10 Ethereum, for example, and it wants to send 20, you can't do that, right? So you first have to make sure that this is actually making sense, that the person is sending more than the value, and otherwise it'll say, as you can see, the token balance is lower than the value requested to send. And so then you're just going to take the balance of the message sender, and this is the same mapping, so the number of tokens, the fungi tokens that the owner has, the message sender has, it's going to be subtracted inside of that mapping, and the to is going to be added, that same value. So if you can imagine, say, a bank that keeps track, it has a mapping of all the users and their balances. It's going to subtract from one user to another when the user wants to send tokens, and it's just going to emit an event. This is just for the contract, things that are useful for querying the blockchain, and it's going to return true. Otherwise, it's going to give an error, but hopefully it is successful, and so it returns a successful message or a true boolean. So that's the transfer function. Now we're going to go to the transfer from. So looking at the comments, value to from is approved from. So the address of the sender is the from parameter, the recipient is the to, the value is the amount. Okay, I see. So this is going to be returning, similarly to the transfer, this is going to be returning from a different address potentially, right? Because the transfer is just the message sender's address. But if the message sender may be approved, then he may have the ability to send tokens from one address to another address that he is not a part of. So this may be the equivalent of me going into the bank and saying, I want my friend to send this much money to my other friend, right? Assuming I'm an authorized user and I'm allowed to do that, that's how that works. So the implementation, transfer from, as you see, there's a little bit more to it. There's an allowance method that is given the message sender. I see. So allowed is another mapping up here. So it maps someone's address to a mapping of allowed users. So this is a mapping of the key is address, and when you give it an address, you should get a mapping of the best way to visualize this, I'd say, is to imagine a table, and each address is a key, and it associates with another table. So each address has its own table. Usually, more likely than not, it's going to be a very small table of just another set of address and their balances. So, and this is just the allowances of, or the allowed users for a particular person. So their address maps to their allowed users who are allowed to spend the money. So require so the allowance is going to be equal to, this is just going to be a new variable that's equal to the from and the message sender. So if you can imagine the mapping of the approve, the allowed, okay, it's hard to visualize this, so I apologize, but it basically just ensures that the allowance is going to be the message sender inside of the approved user of the mapping, and by default, if it's not set, then it's going to be 0. So you might be wondering, how can the message sender be moving money from other people's wallets that don't exist? Well, by default, it's going to be 0 unless there is an allowance defined somewhere else. And this is a less commonly used feature, but nonetheless, it's still a feature. So of course, you have to require that the balances of that from user is greater than the value that we want to send, and that the allowance of the message sender, the allowance meaning the amount that the message sender has on the from user's account or balance, and we got to make sure that that allowance that the message sender has is greater than, of course, the value that we want the message sender to subtract from the from user to the recipient. So the balances of the to user is going to be added to, and the balances of the from user is going to be subtracted from that value amount. And then we check if allowance is less than the maximum amount. Then we have to allow, then if allowance is less than absolute max of uint, which is very rare, this is just a simple check, then we have to subtract that value. This is just going to ensure that that we don't overflow the maximum amount, because sometimes that happens where after you subtract an allowance, this is just a simple check. That basically is almost never used. If I understand correctly, I think the most recent version of Solidity automatically supports these max uints. I could be wrong, but I'm pretty certain that this is not so necessary if statement to have. And then of course we're going to emit that transfer event, and we're going to return true. Okay, so that's the transfer from function. Again, this is an allowance based thing, so not super common to see that. And so, wow, we're almost done. So yeah, this is I'm just going to go over the events real quick. Might as well. We have the transfer from and to, the value. This is just an event that gets triggered, or it's going to get sent to the blockchain. People can query it. People can check if transactions or transfers have happened on a DApp, on a smart contract. Same thing with approval. These are just the events that get emitted on the smart contract. So when you do a transaction, this is what's going to appear as events when they get triggered in the code. We've already seen a couple examples. Emit a transfer, emit an approval. These are just events that are just used for querying on other applications. They may want to query to see if transactions have or have not happened. Alright, so 2 more functions left to go over. Approve. So the message sender approves an address to spend this much tokens. Okay, so this is setting the allowances. This in my understanding, this is going to set these allowance mapping values. So yeah, we're going to give it a spender, and we're going to give it a value, and it'll just return a boolean true or false. So let's look at the implementation. Approve. Right, did I look at that right? Yeah, alright, approve. That's what we're going over. Alright, so simple implementation. We take the allowed mapping of mappings. We give it the message sender, so we're going to see who is approved and the message senders, who are the approved users. And we're going to look at the spender. and we're going to say that's equal to the value. So in other words, the message sender, he's going to have his own associated mapping, so his address is going to be associated with a token value or amount. But then there's going to be this allowed mapping, so each person, each address, including the message sender, is going to be associated with a mapping of approved users. And by default, everyone is going to be on that list, but the value that they are allowed to spend is going to be set to 0. And this one line is saying, okay, we'll set the mapping of that message sender, of the spender that we want to give an allowance. We're going to give it that value that we want to specify. So I, as the message sender, I might run this function, and I might say, okay, I want to allow this user, this wallet address, to have this much value that they can spend from, they can take from my account. So he's going to set that value, and it's also going to emit approval. It's just, like I said, it's an event that gets broadcasted that other applications can query, and it's going to return true that there was a successful transaction. Alright, lastly, the allowance. Oh, this is just going to return the remaining value of the allowance. I see. Okay, yeah, so it's going to take the owner and the spender. So it looks like we do not need, actually we may need to make sure that the owner is allowed to do this. So I'll show you what is going on. So here's the implementation. Yeah, very simple. You don't have to make sure that, so in other words, anybody can get the value that somebody else is allowed to spend on an entirely different person's balance. So somebody has a balance, Bob has a balance, Sally wants to use Bob's money. Sally wants to send from Bob's account. Sally may not have much money, and Bob may have allowed Sally some allowance. Now me, who is not part of either of them, I can run this function and put in Bob, put in Sally, and it will tell me how much is Sally allowed to spend from Bob's address. Very simple. The allowed mapping of mappings, there's going to be the owner, that's Bob. Now he is going to have a list of approved users, or a mapping of approved users, and among that Sally is going to be in there, and she may be given an allowance, and we're just going to get that. And so yeah, this is the ERC-20 fungible token. Very simple, very simple. There's a couple more things right here. This is just initialization. So max uint, like I said before, this is just going to be the maximum value for an uint 256. That's just used for that if check that we saw below. I went over balances, I went over allowed. The public total supply, this is going to be set when you deploy the smart contract. You're going to have to give it this value. So to deploy the smart contract, you're going to have to include a uint 256, an integer value, to represent the total supply. And that's where the total supply comes from. You're going to need a name. Oh, these are optional. Yeah, I got confused for a second. Yeah, so these are just more variables that you're going to have to set when you deploy. You're going to give it a name. You're going to give it how many zeros after the decimal, or how many zeros to represent the coin there are. This is used for other exchanges. They may want to see how, they may want to get an accurate indication of how much tokens there are. And if there are 30 decimals, it may be hard to show it when there's only 8, decimals. When there's only 10 million tokens in existence, there's no reason to put in 30 decimals. You may only want to put 8 decimals. So that's that, and then the symbol, that's going to be basically the ticker. And so yeah, I think I went over everything. As you can see, it's not entirely super complicated when you get into the nitty-gritty of it. It may look like there's a lot going on, but there's just an interface that defines the functions, and then very simple implementations for those functions. And so when you deploy this, given the right values, it will make a new ERC-20 token, smart contract, DApp, whatever you want to call it, that is on the blockchain. and that users can interact with. They can send money to the smart contract. They will do these transactions to send money to the smart contract, crypto rather, and the smart contract will govern how that money is moved around, how things are changed, computational things that may happen, and then eventually the contract may or may not change state. And like I said before, when the contract changes state, when a variable is changed, when a mapping changes, when somebody's balance changes, then this has to be broadcasted throughout the network, and all the users, all the nodes on the network have to approve this change, verify the change, and so that's why it can be expensive. And that's also why I recommend people go to Polygon when they want to make dApps, because Polygon can do many transactions per second, and it can verify things very quickly and very cheaply as well. So that's that. I hope you guys enjoyed this video. I hope you guys got value out of this video. This is my first video on YouTube, so I am going to really care a lot about the comments I get. I want to hear people's input, people's perspective, how people feel about this video, and what they may want to see for future videos. So yeah, that's all for this, and I hope you guys enjoy. Please like and subscribe, comment, and yeah, have a great day.